and will be made available. Now, as I said, the issue that we will be talking about today is setting up your CAM part and tool tables. And by tool tables, I mean everything there is to know about the tool tables, especially, or I should say, including shape tools, how to even create shape tools as well. All right, I'm going to start off first with setting up a CAM part. And I'm going to start with this simple part that you see on my screen over here. Just to make it easy to understand exactly what I'm doing. This is why I created a simple part. As you can see, it just has some radiuses at the edges over here, has some kind of weird shape over here on the side. And I actually want to machine this part out. Now, I also created this part with a configuration. We'll talk about this in a few moments. The configuration that I created is to simulate the kind of a stock I may have. Okay, so when I have stock like this, I like using configurations to help me create the stocks, which is exactly what I did in this case. But we'll show this in the actual working later on as I go through the part itself. Okay, we're going to start our project, our SolidCAM project, by going to SolidCAM part, new milling. Now, there may be things over here that you may already know, but it's always good to go over them, and you'll possibly pick up things that you may have just saw, didn't even realize what it actually does. Again, this is what I'm trying to do. Okay, I am working, by the way, in our newer version of SolidCAM 2013. Okay, we're going to start the part in the beginning. And as you know, when we started a part, we can save it either in the directory where the part exactly exists by clicking on Use Model File Directory, or in your default area, or in any area you want to by browsing into it. Okay, we have our part name. It shows you the part over here that will be loading up, and I always like to keep my part on the screen. This way, it's automatically the one that goes into my CAM project, and we'll click on OK. Now, excuse me. Now let me make this window a little wider. There we go. Now, of course, we have our machine controller that we want to use. In this particular case, I'll be using a Hermelic machine. And we have our coordinate systems and our stock. Now, I like to make up one point. I've seen customers in the past, before they even create a coordinate system, I've seen them actually first go into stock and click on the part itself in order to create a box around the part, even though this is not their stock. And then they would do add CAD to box the CAD model so they can use this later on for creating a home position, to help them create home positions on certain points. This, I want to reiterate, is a not necessary step anymore. This for a while has not been necessary, but I still see customers doing this. This is not your actual stock. That will be later, so don't even bother saving it, because your part itself does not have a coordinate system yet on it, so it's not actually placed where you actually want it to be placed yet. So this does not have to be done now. So I'm going to go out. Instead, I'm going to go as I'd like to start working in my coordinate system. Now, when I click on coordinate system, we have all our ways for creating our, excuse me, for defining our coordinate system. But I like to use the most popular one, which is select faces. Whereas in select faces, we all know that any surface, any flat surface that I click on, it'll automatically give me the coordinate system where the z-axis is perpendicular to that surface, and also at the very top of the part itself. As far as where on the part itself, I can have it, in this particular case, it's marked over here, top center of model box. I can have it corner of model box. I'll just leave it right now for top center of model box and click on the part itself. Now, as we note, you'll see that there's the box that automatically comes up over here, which is why I don't have to originally go as I showed you before, which is why I do not have to go into stock to create this box, because this box is automatically created temporarily inside my coordinate system as I'm creating it. So for example, if I want to say, listen, I want to have my coordinate system on this corner over here, all I have to do in this particular case is just go pick origin and click on this corner, and it'll jump over to that corner over there as shown over here. If I want my X direction to be 180 degrees, in other words, to turn around my Z, all I have to do is click on flip around Z. Every click on flip around Z turns it 90 degrees. So I'll click it until I see my red going in the direction I want it. Now, even if I want to continue, by the way, and let's say I want to move it away from that corner, let's say I want to move it -2 millimeters, all I have to do is go into my delta area and light -2. Z, let's say I want as Y, I want to move it that way in the Y direction. In other words, I can get into any position I really want to just by using these objects without having any kind of special sketches on top or anything else. So the selecting faces can get you almost anything I need with any of these additional tools over here. Okay, let's put this back at 0. Put this back at 0. And then click on OK. Of course, we have our coordinate system data as far as our tool start level, clearance, the depth of the part, and I'll click on OK. And all I want at this point is just one home position, and I'll just accept it at this point. That's all I want is just one home position. Now, as far as my stock goes, I'll create my stock now. Now, the typical way many people work is if they're creating a simple box, all you need is a simple box around the part itself. All I have to do is just click on the part, and since I'm undefined by box over here, it'll automatically create the box around the part. And of course, over here, I can give it excess material as needed, whether it be 1 millimeter in the X plus and in the X minus direction, the Y plus, Y minus, Z plus, I want to have, let's say, 0.5, and Z minus, let's say, at 7 millimeters. So we have all of that done here automatically. That's one way of creating my stock. However, let's say you have a different stock. The stock, like I showed you before, with the little groove at the bottom, we can have it, we can work it a different way. We can choose define by 3D model. Now, when I choose 3D model, we don't see the stock that I had created before my configuration. However, we have our configuration controls right here inside creating the stock model itself. Right now it's on default, but I can open it to stock, the stock that I had. And now we see the actual stock that I want to have. All I do is click on the stock. And if I click on show now, you'll see that will be my actual stock material. I can click on OK to accept it. And of course now, I create my target. Now my target is not the stock, but the actual original part itself. So I'll go back over here to my default and click on the part itself, taking my solid that I need over here. If I were to click on show, you can see that is my target that I want to get to. And then I click on OK. Now, as you see, I did several steps to get to where I wanted to go. Created my, chose my my machine, my controller. Created my coordinate system. I created my stock. I created my target, and now I'm ready to start working. Now, let me not accept this, and I want to start actually working on this part again from the beginning. But this time, I'd like to show you a way, and this is actually something that's actually pretty good for people who work almost always the same way. What I mean by the same way is, let's say you're a machine shop that in most cases you work with only one coordinate system, and in most cases you'll create stock box automatic around the part. We can eliminate a lot of the steps that I've done before, and if I go into my SolidCAM settings, we have our CAM part, automatic CAM part definition. Now, as you can see over here, nothing has been marked, okay? If I go into my stock definition, everything here is at 0. Nothing is marked, everything is left exactly the way it is. My automatic CAM part definition, exactly like I said, nothing is marked off over here. Now, I've created myself a settings already. Now, load this up. And now, with these settings that I have here, my automatic CAM part definition, I have first of all like this. Don't show coordinate system manager after Mac 1 position 1. No, after I create my first home position, don't show me my coordinate system manager. Just go directly to my next stage. My next stage normally is to define stock. Okay, so I want you to define my stock already automatically. And so this is marked off. And define my target automatically as well. If I go into my stock definition, you can see that I have my stock definition set at 1 over here, x minus 1 over there, y plus, y minus. All of this is preset already. Now, just because I have these my settings set doesn't mean I can't make changes later on. But let's see exactly what happens now when I work in this particular way. Again, I'll start my CAM part project. Click on OK. Now, the only thing I really have to do at this point is create my coordinate system. I'll go and create my coordinate system on the part itself. And the moment I click on OK, as shown over here, note, everything is being done for me in the background. My coordinate system manager, everything was done. And at this point, all I have to do is click on OK. And you can see that my stock has already been chosen. I can show it to you over here, the plain box. My target has already been defined, sorry. My target has already been defined. You can see that if I do show, everything has already been done. That doesn't mean I can't go back into CAM part definition and add another coordinate system if needed, or change my machine, or change my stock. For example, if I do want to change my stock, I'll erase the stock that I have over here, and I'll go back into stock, and let's say choose the option of 3D model, and I'll choose my stock option over here and choose that as my stock. Note, even though I created it a different way, it doesn't mean I can't go back and make changes on what I did. Okay, let's continue on now, because I want to get to the subject that's a really more, that I have to get to more in depth, and that's the actual tool table itself. For this, I'm going to already open a part that I started working on. I believe this is it. Okay. And if I were to open up my tool table, okay, we have here several tools that I've created. Let's actually talk about the tool table itself, exactly what's going on and how I create tools, how I import tools, and how I can also create and use shape tools, which is also a subject that not too many people have used in the past, and I'd like to actually have people more aware of it. Now, as you can see right now, I have here several tools in my tool table. Let's first start with this button on the far left-hand corner. This button over here actually shows me all the tools. All tools. The tools that are being used, tools that are not being used. If I were to click on this should show me only the tools that are being used. I'm using actually tools 1, 2, and 3 right now. So the other tools that I had over here, 4 and 5, are not shown when I click on this over here. Now the next one will show me all the unused tools, just the opposite. No, it shows me all the tools that have not been used, and all the tools that have been used are hidden. Go back over here and we see all the tools. Let's look at this area over here now as well. If I click over here, I can tell the program I only want to see tools from 1 to 3. I'll see only those first 3 tools. I can do reset. In other words, it's a sort of a filter. Now over here we even have a little more of an interesting filter. We have the user-defined tool names by type, and if I were to get rid of face mill and only show end mills and click on OK, it'll only show me the tools that are defined as an end mill. Obviously, if I click on face mill and get rid of end mill, it'll show me only the end mills, only the face mill, sorry. Do reset or select all. Okay. Another helpful filter is diameter. I can have a filter saying all I want to see are the tools that are between 0 and 12 millimeters, and click on OK. In this particular case, I only have one tool that fits into that category. Click on here again, reset, or I can click on OK. You see them all. I can say over here, okay, you know what? I want to see all the tools that are between 16 and 100. And it shows me these tools over here. I can actually combine 2 different filters. I can say this diameter over here as well as the type. I only want to see end mills. So I'll only see the end mills that are with these that fall into this particular category of this particular range of diameter between 16 and 100. Do reset. Everything is back over there, and reset this as well. Now we can fool around with our filters. Another important factor over here is, let's say we have our face mill. Okay? Now, our face mill, for example, let's say that it's a particular tool that on this machine, I always keep it in a specific position. Let's say I'm going to give the tool number over here of 20, and on my machine, it is always in the spindle position of 20. So I can mark this as a permanent tool. In other words, it will permanently be number 20. By right-clicking on the tool, I can click on Permanent Tool. Now, let's say I want to renumber my tools. Now, the reason I want to renumber my tools is, let's say today I did my operations with these tools over here. Everything was fine. Next week I have to do these operations again, but these numbers are actually taken up by different tools for a different setup that I have on the machine. So I want to renumber him. However, number 20, since it's a permanent tool, it's in the right position in any case. It does not make a difference. So I can do what we call renumber. By renumbering, I can say, okay, let's renumber it from 10 and on, okay? According to the operation sequence, click on OK. You'll note that all the tools have changed from 10, 11, 12, 13. 20 stayed as 20. Go back over here, put this back at 1. It'll go back to 1, and 20 will still stay 20 because I marked that as a permanent tool. Okay, let me just go a little further on over here in my tool table. We have here the option of showing a tool. We can see the tool in a graphic view over here. And we have another way of showing the tool is the visual tool check. If I were to click on visual tool check, let's move this to the side a little. When I bring my tool mouse to the screen, you can actually see the tool on the screen itself as shown over here. That's because we have visual tool check marked off. Get rid of it and you don't see the tool there anymore. Now, let's talk about delete. A tool that's being used at this moment, such as this tool over here, if I click on delete, it will not delete because any tool that is being used, it is automatically blocked from being deleted. However, if there's another tool here, say this tool, tool number 4, or tool number 4. If I were to delete that, that will be deleted. Okay, let's just click on OK. And now let's continue on now. And I said I'd talk about shape tools. Now, as we'll see later on in this part, I have to mill this part out. And actually, let me just get rid of this operation here. No, that's fine. That's good. I have to mill this part out. So obviously the best way to milling this part out, now just run my simulation over here. And my first operation is my face mill going on top. Then the best way for machining around the part is using eye machining. So I did an outside machining for the eye machining over there. There as well. And then I cleaned out the pocket as well using eye machining as shown over here. Okay, so everything is machined out really great until the very end. That's fine. Now, what we have left here to do is we have to do these edges over here and this area over here. Now, let's first talk about these surfaces over here that I have to be machined. Now, obviously, if I want, I can use HSM or HSS, but there are tools in the market today, there are shape tools in the market today that actually can do these type of operations, putting a radius on the part itself. Now, the radius over here is a 3mm radius. So let's actually create a tool with that particular shape. To do so, I'll go into SolidCAM, and I'll go into Tool Library, Shaped Tools. Shaped Tools allows me to actually create any type of shape tool that I want. Literally any shape that I want. Now, let's go to the bottom, and I'd like to add a new tool to the very bottom over here. Now, I said that this radius over here is a 3mm radius, so I'm going to create a tool that looks similar like this with a 3mm radius. I'll right click and just right click on add to add a new tool. Now we have a new way of doing this in 13, in SolidCAM 2013. All I have to do is start by adding shapes. The first shape I like to add is a cylinder. So I'll click on the cylinder shape. I can give it a value. Let's give it a diameter value of 12 millimeters and this a length of 40. Actually, I'm starting with the shank of my tool. Now, at the very bottom, I want to add on another part to my shape tool. So I'll right click on this area itself here, and I'll say add shape below. Which shape do I want to add below? I'll take this shape here as well. This time, I'm going to make this at 16 millimeters, and this here at 10 millimeters. Something like this. Now, the next shape I'd like to add at the bottom, add shape below, is this shape over here, giving me a radius at the bottom over there. Now, the radius that I like, first of all, many times you'll find that the edges over here on this type of a tool, which is a very familiar tool, by the way, a lot of times they'll be straight at the very beginning of 1 millimeter and then start the radius. So I'll make the top diameter, instead of 16, I'll make it at 14 millimeters. And the radius, like I said, 3 millimeters. So now we're set over there. Now, let me add one more part, because a lot of times you'll have at the very bottom 1 millimeter that goes straight to the bottom. So I'll right click over here and add another shape to the bottom. And as you can see, all I'm doing is going on and on, adding these types of shapes over here. I'm going to make the diameter over here. What was the diameter over here at the very bottom of this one? This bottom diameter here was 8 millimeters. I'll do the same over here for this. This is 8 millimeters. And this here height will be set at 1 millimeter. So the tool actually looks like this. This is a typical tool that can be had. I can right click over here at the tool that I just created and just give it a name as well. Rename it. I'll give it a name of R3 with a diameter at the bottom of 8 millimeters. Okay, now it's important to know the diameter at the bottom over here. Note we have several diameters. We have this one and we have this one. The question is, what diameter are we going to actually give to the tool itself when we use it? And we'll see that in a moment. Okay, so like I said, we have the tool over here that I created. And note, the moment I create it here and click on OK, it is automatically saved in my shaped tool library. Now, let me start now with my option of using that tool. And in this particular case, I want to mill out this edge over here and the outside one as well using that particular tool. So I'm going to use an operation of profile, a simple profile operation. I'll create my geometry. I'll start first with my inside one, automatic Z. Note, I pick the inside wall over here. Okay, not the top, but the inside, because that's exactly where I want the side of the tool to get up to. So that's where I'm going to be working on with that tool. Now, next I'm going to pick from here, and I'll do automatic to this edge over here, and accept that. Okay, so I have my two chains. Now I need to create my tool. I'll go into Tools, Select, and I'm going to create now a new tool. I'll use a regular end mill. Okay, and now I'll go into Shape to bring up my Shape tool. If I go into my global settings, you'll see that I have in my new groups where I created my tool, I have my tool over here, and I'll just click on it. Now, if you remember, if I go into my Shape Edit over here and edit, you'll see if I take the very last bottom cylinder, which is over here, you'll see it's 8 millimeters. That is the diameter the tool has to be set at, 8 millimeters, because that's the edge I want to hit my part itself, to get to that particular geometry. So we have it set at 8 millimeters. Of course, over here I have my number of flutes, the length, and note. It automatically puts in the length according to the shape tool that I put there. And I'll click on select. And as you can see, we have the tool. Now, as far as the levels go, my profile depth will be up until this corner over here, this edge over there. However, since I have an excess of 1 millimeter at the very bottom of my tool, I'll just put in a delta of -1 millimeter to go 1 millimeter further down. Now, in my technology, I can do a finish cut to do it all in one shot, or if I want to go in steps as I'm working my way in, not to take it all in one shot, I can actually do a rough. Let's have a step down. If I step down all in one shot, so I'll have it at 0, then it automatically goes to 1 shot. And I'll have my wall set at 0.1. Now, to have it go in gradually, I'll use my clear offset option. How much? Let's see, I have a 3 millimeter radius over here, and I want to go in and start with 2 millimeters and step in every millimeter. Let's see exactly what happens. Oh, don't forget your link. So we'll use our link with an arc of 5 millimeter radius. Same thing with my lead out. Let's click on Save and Calculate and Simulate. If I run my simulation, you can see my simulation goes around the part itself. Actually, let's use the Solid Verify simulation so we can see it a little better. You'll see my tool goes down. And you notice it's going in steps, not taking it all in one shot. Let me just zoom in a little over here. Until it gets to the very end. Now, it's going to do the same thing on the outside. And everything has been machined exactly the way it was supposed to be machined. So you can see, you can use a tool, a shape tool of this time, inside our program itself, just by creating the shape tool. And if you have several of these types of tools, it'll always be available once you create them. Okay, now we still have, as I said, one area of this part that still has to be machined. Now, you may work like this, you may not work like this. The idea is to show you what you can do with shape tools. I have this area that has to be machined out. Now, I decided I wanted to use a shape tool to save on tools or to save on operations or for whatever, or just to save on setups. I want to have one tool do this area over here. So for that, I went out and ordered a special tool. Let me just show you how this tool will look. If I were to show you the tool itself, it's a tool that looks like this. We have the exact shape that I need over here, even with an excess of an extra millimeter on top over here, 4 millimeters instead of 3 millimeters. Okay, this is the actual tool I need. Note the diameter at the bottom over here is 12 millimeters, and the diameter over here on top is 20 millimeters. Okay, now let me just put this on the side. I created this tool in the exact same way I showed you before. I have this tool already done over here, so I can show you exactly how it looks. If I would go into, if I go into Shape Tool for a moment, open up my Shape Tool and go to that Shape Tool that I created over here, you can see that I already have this tool over here that I created. And I created it basically in the exact same way I created that other tool, just adding on shapes as I go along. Okay, so let's see now how I can use that tool. Again, I'll start a new operation. I'll use a profile operation. And my geometry in this particular case is going to be this edge over here. That's it, just that edge over there. I'll accept that. The tool, I'm going to create a new tool. Again, I'll use my end mill. And my shape, I think I even have it out over here already, is this shape over here. Okay? It's the shape that I had at the very bottom, as I showed you before, over there. So I'm going to use that particular tool. Now remember, the diameter at the very bottom was 16 millimeters in this particular case. I have one over here that's 16 millimeters. Not a problem at all. So the diameter I need to put in this area over here, my topology, is 16 millimeters. Because that's the edge I want to get to go into up to my geometry over there. I'll choose a tool. My levels will be up until this step over here. And my technology, I'm going to use the exact same technology I did in the previous part. I'm going to do a rough and finish, set this at 0. And again, I'll have a wall offset of, say, 0.1 millimeters. And a clear offset, let's see, if I do clear offset from this edge over here, that shows it at 5 millimeters. So I'll make it at 4 millimeters, my clear offset. And to go in every 1 millimeter. Notice my first step will take off 1 millimeter off the part itself, and then every single time it goes back, it'll take off another millimeter. Again, we have our link area. This time I'll use tangent to go into my part. Let's say we'll start from 10 millimeters out. Have my lead in, same as my lead in. Same as my lead out, same as my lead in. Save and calculate. Run my simulation again using Solid Verify. You'll see now that my tool will go down to the depth I need, and it'll take its first step across the part, working its way in. And every single time it'll go in more and more until it gets to the very end, to the exact shape I need. Now here we can see another way I can use my shape tools. So using shape tools can be used in the program. What's important to remember when you use a shape tool is the diameter value that you put inside over here is the diameter that you actually need of the tool to get to the geometry that you've chosen over here. As you note on the tool itself, the shape tool itself, there were several diameters. Therefore, it can't be put in here automatically. You have to decide which is the correct which is the correct diameter for your particular operation that you're using. Okay, I'm going to stop here, and I'm going to go through the questions. Again, don't forget, you can still ask the questions if you want. Write it down in the proper area. And I do see I have several questions, so let me start. Okay. Okay, there's a question when I start a new part over here. Someone had asked the question. Sorry. About internal, external. I can't open a new external cam if I have assembly. It will only it will use only one part. If I use internal, all is fine. that you have, whoever asked that question, you would have to put that towards your support and actually sit with you on your part to see exactly what you're not doing correctly. The way this normally works, by the way, internal and external, internal mode is used for if you want to use the part, it'll actually create everything within the SolidWorks part. This is especially useful for people who only have the option of using of SolidWorks with parts itself. It'll create everything within the part itself. If you have an assembly part in the beginning, you should be using external. But if you want, you can use internal. But this is a separate issue itself. And when I do a webinar, I'll be doing a webinar in the near future on what's new in SolidCAM 2013, and we'll be talking about this as well. But in this particular case, please ask your local support to help you out with this if you're using it already. Okay, as far as old webinars that I've done in the past, we will be opening up in our site very shortly. It should be open up within the next few days. We'll be opening up a new tab inside SolidCAM itself. A new tab over here will be called SolidCAM University, where all the old recordings, all the recordings that I've done on previous webinars will be available for everyone to see. So a little more patience on that. It's being set up now, and hopefully within the next few days we'll be able to send it. However, I will be giving this, these will be available to your resellers through our channel manager over here. And your reseller can actually get it. Can actually get you the link to these to the webinars in any case. But we will be creating in our site over here another tab called SolidCAM University, which will have all the recordings there as well. Okay, question: if I change the feed and speed in the part tool table, how can I force the CAM job operations already programmed using these tools to use the new data? Okay. Let me open up a part that I just had before. I'll open up the exact same part. Now, obviously I'm not going to take an eye machining operation because it doesn't look at it at all, but let's look over here. In this operation, we have our tools, okay, and we have the data that was given over here, our tool data, okay. Obviously, in this, I can change it over here, but let's say it's being used in a different operation as well, so I can't change it over here, but I can change it over here in the data itself. Now, the question, however, was if I make a change in my tool over here, how can I force it to actually go to this tool that already exists? There's several ways I can do this. First, let me first go into tool itself and make that change. We're talking about T4. So I'll go into T4 itself, go into my tool data, and change my feed XY to 2000. Okay, and my spin rate to 3000. Okay, irrelevant whether it's correct or not correct, that's not the point right now. Now click on OK. Now, obviously, this tool itself does not have, it still has it. If I choose it over here, you see it has the new feed. If I re-choose a tool, in other words, say select again, and it comes with the new values that I've done in here. That's one way of doing it. Okay? Now, I didn't accept it because I just want to show you what you normally have. Normally, if I don't choose it again, if I go into Tool and I go just into Data, it still has the old data over here. But if I go into Tool and re-choose the tool itself, then it'll change everything here that I have. Now, one more thing I can do. Note, there's an option to be able to see your tool on top of the tool list itself. So for example, if I would go into my operation, right click onto operation, we have CAM tree view. It says show tool in tree. And I want to click on show tool in tree. As you can see, we can see now the tools itself that we have in our tree. Now, if I were to right click on the tool itself, I can do change tool data. Now, if I had several operations, I'd see all the operations over here with that data. And if I change the data over here, it'll automatically change it in all the operations that are using that particular tool, or every one that I've checked off to use in that particular tool. We'll also be adding, by the way, another option over here that will, if I click over here, make the changes over here, another option saying that make as default values is another option that will be added in here as well, so that I don't even have to go into here to change it. I can change it from here as well, and it'll change it also for the operations, plus as my default value for future operations as well. Shape tools in machine simulation. Let me see about that. Even though I don't know if I didn't set up my machine simulation over here, but let me hold on a second. Let me just go to this operation right here, run simulate. Let's see if I can do this with machine simulation. We're just looking at the tool right now. We're not looking at anything else. No, it does not. Right now, I can't give you an answer on that. That I would have to check with the development department over here to find out if and when we'll be able to see the actual shape tool in here as well. I have no answer for you on that one. Sorry. Okay, now one more thing. If I were to create a tool, let's take the first tool over here. If I go into tool data, cutting conditions, I can add actually work material over here. This is something that I had to do beforehand. But I can actually have a list of different work material, and it'll automatically put in the feeds for that material, a tool according to that material itself. There's something that has to be set up beforehand. I don't have this set up here right now. However, by the way, as we all know, that in iMachining, this does not have to be done at all. As far as iMachining goes, the feed and rates do not have to be taken into consideration with the material, because iMachining does that automatically according to the material itself. In the regular way, I have to do a little homework first. First preset certain options over there in my tool data. In my tool library, I have to set up cutting conditions and put in different feeds and rates for different types of materials. and change it according to, I can add cutting conditions, work material, feed. I can put work material here as AL. I can put a feed in here as, I can put cutting conditions, sorry, here as, let's see, 10 to 12 as in diameter. Or 10 to 13. Feed, all these values I can put on over here. I can add more feed, let's say 1,000. Feed finish. I can have this as a 500, whatever. Spin rate at, let's say 5,000. Finish bin rate, sorry, 5,000 I said. Finish bin rate, I can have it at, say, 5,500. I can create another one. Do the same thing over here, 12 to 13. Working material, I'll call this 1020. Over here, I'll have a different feed rate. I'll have this at 500, and so on and so forth. I'll have this at 400. This one at 3,000. This one at 3,500, and click on OK. Example. If I go into my tool itself and go into, say, this tool over here in my tool data, I can do cutting conditions, import from my global, and then I can just say, okay, those are my cutting conditions, and import those. And those values will be imported over there. If I go back over here, I can open up my global again, say use this instead, import those, and the values will be changed as well. Okay. Is it possible to create shape tools for turning? It will be. It is not available yet, but it will be in turning as well. Especially now that we were introducing now as well. We're introducing now also the option of manual tool turning inside turning itself, which is a perfect case for where you actually would need to have a shaped tool in turning as well. So yes, it is on its way, and it should be in here very, very shortly. Definitely by the next version, it'll definitely be in there. Okay, thank you everyone for joining the webinar. I hope we shed some light on some of the options that we have in the program. And our next webinar, by the way, will be on the subject will actually be the use of toolbox operations. Something we have in our program now. It's been here for a little while, but nobody seems to know exactly how to use it properly. So I'm going to go through toolbox cycles inside the program itself. Okay, thank you very much for joining. Have a great weekend, and we'll see you next time on our next webinar.